Hello there and welcome to this Pandas Library Challenge, day 20 of 30. My name is Valentine and I'll be your instructor. In this challenge, we'll be continuing our journey of learning how to use Pandas for data analysis, and we will cover some new concepts as well as some past concepts that we have practiced. So let's get started. The first thing that you need to do is to visit the description section of this video, and you'll find a practice resource link that will take you to this page. And then once you get to this page, click on the sample practice resource, which should take you to the notebook that we're going to be using for this workshop. Feel free also to pause the video just in case you feel like I'm too fast. And also for the challenges section, we'll be providing exercises for you to practice. So we'll be prompting you to pause the video so that you can be able to practice that concept. That way, at the end of this learning experience, you're able to showcase what you have learned. So yeah, click on that link, get to this page, and then we can continue. Once you get here, go to File, then save a copy of this notebook to Drive. And you should be able to now use that new copy. You can close down the original one. And the idea is that once you write your code in that new or the copy one, you can always save that notebook and come back to that notebook. If you don't follow that step of saving, so of going to File then saving a copy, then you won't have any changes made to the notebook. And in the future, if you want to refer to the same notebook, you would have to start from scratch. Right, so once you do that, by the way, if you're an Afterwork member, you'll get access to the practice notebook. So for those who are Afterwork members, there are many more resources that you get aside from just the practice notebook, which is just more like what you have in the sample notebook. The only difference is that you have more challenges. For each section, you have the challenges. And also you have access to a solution notebook that you can be able to use to verify the solutions that you've created for the challenges. Right, I'll be using the practice notebook, which again, it's just similar to the practice notebook, only that, or to the sample notebook, only that we only just have a few more challenges in the practice notebook. All right, so so once you get here, just go to prerequisite, then run the first cell. I'll zoom in a bit more so that we are able to see a bit more clearly. All right, the first step that we do, we import the Pandas library for data manipulation. So that's what we've done. Then we can get started with the first concept. Assuming that you wanted to determine the relationship between two variables in a data set, we can use several methods to determine whether those variables in question have some sort of relationship. So it could be that we'd want to determine whether there's some sort of correlation, which means is values of one variable increase or decrease, the other values of the other variables also decrease or increase. So we might want to determine whether there's that relationship. So we can use we can use a scatter plot, which is a visualization that helps us to be able to see that particular relationship or behavior in or between just the variables that you're working with. So assuming that we had this data set that we load, and we would see that it contains information about products, groceries product to be specific, and assuming that we wanted to determine whether there is a relationship between price as well as sales, then we can create a scatter plot using Pandas. So we would reference the DF data frame, use the plot function, specify the kind value of the plot function, of the kind parameter of the plot function to have the scatter value. Then we set what we would want to have on the x-axis of our scatter plot, as well as the y-axis and the title. And this should essentially give us a scatter plot that helps us to understand whether there is a relationship. In this case, the relationship is quite weak. it's quite weak because we do not necessarily have values increasing as the price, also values of sales increasing as the price increases. Some of them do show that there's that correlation, but it's not as strong because the majority of points are on the left hand side. We could use the correlation coefficient to determine exactly that figure that will tell us to what extent those two variables are related or correlated. But for now, our focus is just being able to create a scatter plot. Right, pause the video and then work on the challenge that follows. That should help you to see how you can also implement a scatter plot for a different data set. I think for this data set, we have total sales versus expenses for this particular data set. Right, pause the video and then work on the challenge. Aside from creating a scatter plot, we can also create another type of visualization, such as a line plot, to showcase how values change over time, or over, just generally over time. So assuming we had this data set that again contains products information, slightly different from the previous one. But if you wanted to determine how quantity changes with respect to the sales date, then we can use the line plot function, the line plot. So again, we would first of all need to convert the sales date or the date column that we want to work with, which is the sales date column, to date time format. And then once we do that, we can decide also to sort those values by sales date. Sometimes you might have data that has the date not really sorted, so we could do that just for ensuring that we have a date that is consistent. Then once we do that, we can then plot our function. We almost actually use the same function as the scatter plot. Here we just use plot function. The only difference is that we set the kind parameters value to line to create a line plot, and then we set the x-axis value or variable and the y-axis variable in the title. All right, that's it. That's what we got. And yeah, pause the video and work on the challenge that we have here. Moving on, in some cases, we might want to transform or clean data before performing maybe visualization or creating tables that we can use for answering research questions. So we can use what is called we can use an apply function. So we can decide to use an apply function to apply another function that will perform our pre-processing task. So if we had this data set that we have here, which still contains information about groceries within a particular store, then if we wanted to convert this price, which in the case would by default be in the US dollars, if we wanted to convert it to euros, then we can define a function for that, which we do here. We define the function, which is USD to euros, and inside it we provide the relevant operations that will take in some input, which would be the price, and convert it to some output. Then we apply that function to the column that we would want, say the price column, and that would essentially give us the desired output, which is a price euro. The price is in euros. So here we create a new column. But again, how we calculate the euros is that we apply this custom function to the price column, and the output is stored in price euros, and then we can preview that. Right, pause the video and then work on the challenge. In some cases, we might want to delete rows by a condition based on a specific column value. So for example, if we wanted to delete rows that are not relevant to the research question, then we can decide to perform some, one of the ways that we can be able to delete those rows is just selecting those records that are not, selecting the records that are only relevant to analysis. So assuming that we had this data set and we wanted to, this is a data set that I'm going to load, and we wanted to select records, or we wanted to work with records which did not have a discount of 0. So if the discount is more than 0, then we can decide to set the condition, which is f discount is not equal to 0. So the discount column is what we have here. Like one of the columns that we don't want to work with is this column because it has a discount of 0. And then this will essentially just get all those records that don't have discount as 0. So it basically negates. So we use not equal to operator to be able to perform that operation. And we get the output, which will contain the data set that contains discount greater than 0. Well, it could be, yeah, just greater than 0. We can't have negative discount. Right, pause the video and then work on the challenge. In some cases where we might want to prepare data for machine learning, we might decide to convert the data that we have into numerical format. So assuming that we had this data set and we needed to use this data set to train a machine learning model that makes some sort of prediction, whether that's of regression nature, of classification nature, then we can decide to convert the categorical variables that we have here into numerical representations. Well, there are many ways, but one of the techniques that helps us to take into account of even the order of the category that we have in our categorical variables, the order of values within our categorical variables would be the ordinal encoder technique, which essentially not only just assigns value to the values that we have here. So assuming that we had category, assuming we wanted to convert this to using the ordinal encoder to a numerical representation, yes, fruits, dairy, and bakery would be given a number, but at the same time, there would be some sort of natural order that these particular values will be given. Another example would be assuming that we had a categorical variable called temperature, and we had low, medium, and high values. So instead of fruits, we have low, medium, and high values. Then the ordinal encoder would assign low to, would assign 0 to the value low, and 1 to the value medium, and 2 to the value high, therefore maintaining some sort of natural order when it comes to just basically encoding. So essentially, the ordinal encoder, in this case, would transform the category variable that we have here into a numerical representation, but taking again into account of some sort of order, natural order. That's what we do here, and the outcome is what we can be able to see on the far right, category encoded. So because we've created a new column called category encoded. Right, pause the video and then work on the challenge. In some cases, again, when we don't want to work with data that does not help us to answer a research question, when we want to work with data that only helps us to answer a research question, then we can remove the unnecessary data. In the past, in the previous concept, we showed how we can be able to delete rows, but now we're going to learn how to delete multiple columns. So first of all, we can decide to, once we have loaded our data set, which will just contain just product prices or products, we can decide to, first of all, create a list of those columns that we don't need, and then pass that list to the drop function, which will drop or delete those columns. And it will also make, when we set in place to true, it will make the change, which is the dropping or deleting of those specified columns. It will make that change permanent in the original data frame, and then we can preview the final data. So you can see we have a data set that's slightly smaller than the other data set that we had initially. All All right, moving on, we can also decide to drop records with missing values in specific columns. So in cases where, again, we are cleaning our data before performing data analysis or visualization, we might only want to delete records which have null values in specific columns. Maybe we might find value in retaining records with missing values in other columns. So yeah, we might want to leave them out, but if we want to delete records with missing values in specific columns, as in the case of this example, we might have this example which has some missing values like in the discount column. So assuming we wanted to delete the records that have missing values either here or here, then what we can be able to do is to first of all specify the list of those columns that we want to delete records for if they have missing values. So specific columns are those ones, price and discount, and we pass that to the subset parameters. So it becomes the value of the subset parameter, which is part of the drop NA function. So yes, we will use a drop NA function, but we will subset, we will set the subset parameter to the columns that we want to use to define the columns that we want to specify in the deletion process. So and then we just display the clean data set. So if we display here, you'll even see record 3, which has index 3, is no longer there. All right, pause the video and then work on the challenge. In some cases where we are handling missing values, we might want to replace the missing values with some sort of constant or some sort of, yes, constant, whether it's a string or a number or integer or float, we can do that. Let's just load this data set that will give us, it's actually a similar data set as before. It shows us we have a missing value for discount column. If we wanted to fill in the missing values with just a -1, so we would actually pass that as the first parameter in the fill NA function and then set in place to true to just make the changes to the original data frame. So if we run this, we should be able to see that we do not have any missing value for that. So here would be -1. But again, -1 doesn't make sense for discount. We would have to change this to something that makes sense. All right, pause the video and then work on the challenge. In some cases, we might want to use what are called pivot tables, which are summary tables, to be able to answer research questions. And sometimes pivot tables, just simple pivot tables, may not do, and we might need to create some complex pivot table. So assuming that we wanted maybe to create a pivot table, but again, a pivot table that contains that groups data by 2 columns, but at the same time also calculates some, performs some operation across 2 different numerical variables. So for instance, if we had this data set that contains, again, information about products, and we wanted to create a summary table, and that summary table would have category on the left-hand side, as well as brand that comes after the category column, then price and quantity columns. For price, we can define that we would want to have maybe the mean price, and for quantity, it's a sum price. So what we can do is just use a pivot table function and then pass the data frame that we want and set the index, which are the 2 columns that we are going to be grouping by. And the values, the 2 columns, numerical columns, we could set them using the values parameter as shown here in a Python list. Then use the functions that will be used to calculate the values for those 2 numerical variables. So for price, we want to calculate the mean for each brand per category. The same case for quantity, want to calculate the sum for each brand per category. And we just apply reset index to have an output that's Pandas data frame. And here we go. All right, pause the video and then work on the challenge. Lastly, once we have finished data cleaning, in case we want to refer or to share to refer to that data set in the near future, that clean data set, maybe in a few weeks time or months time, or even if we want to share this data set to some with some other stakeholder, what we can do is just export the dataset as a CSV file. We could also do that within other formats, but in many cases we just use a CSV file. So assuming we had this dataset, and it was initially not clean, so we performed some data cleaning steps, which here we just dropped a few columns that we may not need for our analysis, then renamed the columns for just better readability. Then once we have performed our data cleaning steps, which are what I have highlighted, we can then export the clean data, which would be in the df cleaned data frame, and we can be able to export it using the to CSV function and specify the name of the file as well as the path. So this is the name of the file, .csv, and the path. We could have a folder in here at the very beginning if we had a folder in this place, and we set index to have so that we don't have an index column shown in the CSV file that we are exporting to, and then we just print out the message. But here I can just show the data showing up on the left hand side when I run this. So if I run this, our data has been exported, but if I refresh it, should be able to see it here. You can download it if you want. Right, pause the video and then work on the challenge. All right, so that's it with regards to this learning experience. I hope you found value in this challenge and you were able to practice and be able to feel like you're able to just recall these concepts without a lot of effort, because I mean some of them we've covered almost all. Yeah, so if you did find value in this learning resource or this video, be sure to give this video a thumbs up. It helps us to know that we're doing a good job, and also helps other people to know that this is a valuable resource. And if you'd want to be informed when we post the next video, the next resource, or the next challenge, be sure to subscribe, and see you in the next challenge. That will be on day 21. Bye-bye.